Into an important topic in medicine which we call the hemostasis, or how your body stops bleeding after an injury. Understanding this process helps us to appreciate just how well our body are designed to protect us. So let's get started. First, what exactly is hemostasis? Hemostasis is simply the body's way of stopping bleeding to prevent blood loss when we are injured. It's simply like an automatic repair system that involves three main steps. The first one is what we call the vascular spasm, platelet plaque formation, and the coagulation. But before these are the two main pathways. But before then, we have at the middle here, we have what we call the vascular spasm or vasoconstriction. The word vasoconstriction is a combined word, which is vaso and then constriction. Both words have been derived from the Greek word, which is vas and then constrigere, which simply means vessels, and then the constrigere is to tighten up. So when you relate this to hemostasis, this is a very first response when a blood vessel is injured. It quickly narrows, reducing blood flow to the wound. This vascular spasm buys time for other things to happen. That is, for other steps to kick in. The next step that is going to happen is what we call the formation of the platelet plaque, then the coagulation cascade, which we are going to look at it one by one. We have the major component of the hemostasis, starting from the vascular injury. Here we have injured blood vessels, and we have seen the tissue factor, exposure of the tissue factor and exposure of the collagen. We have seen the first step, which is the vasoconstriction. The second one is the platelet activation. So notice that platelets are tiny cell fragments in blood. What they do, they simply rush to the site of the injury. When they encounter the exposed tissue, they become sticky and clump together, forming a temporary plug to the patched wound. The platelet activation is not that very strong, so it's simply like a placeholder until the real repair happens. So we're done with this. The next thing we're going to be looking at is the coagulation cascade. The coagulation is simply the process, or we can also call it clotting cascade, and it involves three main steps. The first one is what we call the intrinsic pathway, intrinsic, extrinsic, and the common pathway. The vasoconstriction and the platelet activation, they both fall under the primary hemostasis, and coagulation cascade and antithrombotic control mechanism falls under the secondary hemostasis. So the most important part which we're going to be looking at now is the coagulation cascade. The coagulation cascade basically have three main pathways, which is the intrinsic, extrinsic, and both of them lead to the third pathway, which is the common pathway. Notice that the extrinsic pathway is faster and is triggered by what? External trauma to the blood vessels, like cut. You can have a cut. And this cut can lead to what we call the tissue factor, which has been denoted by TF. So this damages exposed something which we call the tissue factor, which bind with factor 7. So I'm going to draw it somewhere here. Tissue factor actually bind to activated factor 7. Here we have factor 7. The activated one is going to be factor 7A. So when these two, they quickly went ahead and activate factor 10. We have the intrinsic pathway. The intrinsic pathway is actually triggered by damage inside the blood vessels. When the blood vessels lining is disrupted, blood is exposed to collagen in the blood vessels walls, which activate a protein called factor 12. So for this site, we are going to have, this will activate the protein which we call the factor 12, but the activated one. Here we have 12. 12 will then activate factor 11. Activated factor 12 will activate factor 11, which is going to be this. Then will now activate factor 9. Factor 9 is IX. IX, the activated one, is usually denoted by I. So then factor 9 will activate factor 7. No, sorry, factor 8. Which is going to be VIIA, which is activated. This is slower, so the intrinsic pathway helps to amplify and sustain clotting. Intrinsic and intrinsic pathway kickstart a common pathway. So the common pathway where factor 10 became activated. The activated factor 10 combined with factor 5. Activated factor 10 combined with factor 5 to form a powerful enzyme which we call prothrombinase. And thus, it simply convert prothrombinase convert prothrombin into thrombin. And notice that thrombin is a key player because it turns fibrinogen. And notice that this fibrinogen is a soluble protein. So the thrombin converts fibrinogen into fibrin. And this is insoluble. And this is what forms what we call a long strand. So next thing we're going to be looking at is the fibrin and clot stabilization. Fibrin is like a glue that binds everything together. This fibrin strand weaves through the platelet plug, trapping red blood cells and reinforcing the plug into a stable clot. So to make things even more stronger, another factor, which is factor 13, will come into action this time around. We're going to have factor 13. What it will do, it will simply cross-link the fibrin strand, creating double mesh that will seal the wound. The clot forms, the platelets contract, pulling the edges of the wound closer together. And this is what we call clot retraction. So once the blood vessels heals, what really happens is that the body will slowly break down the clot through a process which we call the fibrinolysis. So the enzymes involved in this is what we call the plasmin. What it does, it digests the fibrin and clears away the clot, restoring normal blood flow. So hemostasis is amazing and complex that protects us from blood losses while making sure blood clots don't form when they shouldn't. I hope this video helped you understand how your body maintains this delicate balance. So thank you for watching. Don't forget to click on the subscribe button. Thank you. Into an important topic in medicine, which